So how was it for me? Gosh, it was kind of complicated to understand this lesson.
Hmm.
It's the wording, the way that it's explained. I don't know if it happened to you, but the word means is repeated so many times that it gets really confusing sometimes. I don't know.
Yeah, definitely.
Oh gosh, that word was driving me crazy because it was like the distribution of the mean and the mean, and I was like, oh,
Hmm.
yeah.
So
But
many different meanings.
yeah, yeah, I saw what I did is I look on YouTube a tutorial. It
Hmm.
was useful. I can send you the link if you want. It was
I,
very clear.
I saw
Um,
the accompanying video to the lesson. Like
mhm.
it kind of explained it, but um, like like you said, it's still a bit confusing.
Yeah, that one I saw too, but I found this other one. Let me send you a link. You can look at it later if you want. But I found the other one a lot more like easier to understand.
Hmm.
Um, so it was not a PowerPoint. The guy was actually writing it on a kind of on a blackboard and doing all the graph, and it was for me at least was really easy to understand. Let me look for the oh, if I can find it. Okay, yeah, I would have to look on my on the history. Okay, if I don't find it now, I can send it to you later. But it was pretty easy to understand on that
That's
one.
fine.
Okay.
Hmm.
Okay. Do you want to check the quiz to see?
Yeah,
Okay, good.
yeah. Let's see.
Let me share my screen so I can put it up on
Let's,
it.
like I've already gone through and put in my answers, but I haven't submitted it yet. I wanted to see
Yeah,
what you thought before.
I did the same thing. I have it ready, but I haven't submitted yet neither. So, okay, can you see it? Yeah.
Yeah.
Okay, good. Let's see. Okay, why it's not allowing me to scroll down? There we go. Okay. So first question, which of the following is the best statement for the law of large numbers? I selected this one. If the sample size is large, the sample mean will be close to the population mean.
Oh, you're doing the homework quiz, not the group meeting quiz.
Oh, that's a homework quiz?
Yeah.
Oh, dang it. I got that wrong. Okay.
You could probably save your progress and then pick it up later sometime.
Yeah,
I don't think it's due until like this weekend.
yeah, I didn't notice that. Sorry about that.
That's okay. At least you can say you're ahead now.
Yeah, but still have to do the homework, the other group quiz stuff.
It's okay. We can go through the we'll go through the group meeting quiz together. That's the
Okay.
idea.
Let's see if it saved it. Saved it? Yeah, it's not saved. Okay. Go back here. Sorry about that.
That's all right.
Da, da, da.
It was up there.
It's up there?
Yeah. Let's see. Right there at the top.
Oh, group meeting quiz. Right here. Yeah. I skipped it. Okay. Okay. Okay, so question 3. When you're taking a sample size of 5, what is the shape of the distribution of mean histogram when the parent population is right skewed?
I would say it's right skewed. Like that's not a very good big sample size at all.
No, it's too small.
Mhm.
If it was larger, it would get close to normal. That's what I understood, right?
Right.
Okay.
That kind of goes
Uh,
into the next question. Like the sample size is much larger.
that would be normal then.
I would think so.
Yeah. Okay, so you're taking a sample size of 5. What is the shape of distribution when the mean is when the parent population is normally distributed?
I would say that's normal.
Normal too. Right. Okay. It is shape of distribution when the parent population is normally distributed. This is I don't
Still,
know. This is 5. Okay. No, wait, because okay, wait, where am I? This is 100. Okay, this is we are number 5, right? When you're taking a sample size of 5, what is the shape of the distribution mean histogram when the parent population is normally distributed?
Oh, hey, what's up, guys? Sorry I joined in late.
Oh, that's fine.
That's all right.
Hey, what's up, Cyrus? How are you?
Good, how are you?
Good, good. Well, we finally made it, the 3 of us. That's good.
Yeah.
Um,
We're going through the quiz right now. You got it up?
Yeah, just give me 1 second.
okay. I'm sharing my screen in case if you don't have it there, we can look at this. Um, so Cyrus, Colin was telling us that the instructor sent an email and probably somebody else will join our group. We don't know who that is yet, but um, hello, can you guys hear me?
Yeah, I hear you.
Oh, okay, okay. I thought I lost you for a second. Uh, I think we lost Cyrus. Yeah, yeah, we
Yep.
lost him. Okay, let's give it a minute to see if he can get back, connect back. Okay. So Colin, where are you at? Where are you in Idaho or?
Yeah, I'm here on campus actually.
Oh, you're in campus. Okay.
Yeah.
Cool. That's good. I'm down here in Uruguay, South America.
Nice.
Yeah. How is live in campus there? Is it nice?
Yeah, it's nice.
A lot of snow, isn't it?
Not this time of year,
No?
but yeah.
Oh, cool. I was close. I was in Utah back in December for holidays. My wife's
Yeah.
family lived there, so
Oh, good.
the holidays there.
Hey, what happened?
Sorry,
Very
the
good.
reason I was late is because my Wi-Fi's been in and out all day, and it just went out again. So
Yeah, yeah, we can tell. Okay, okay, let's try to get this going then before you get disconnected again. Okay, so we were going through the group quiz. Did you have the chance to review it, or you can?
yeah, I went over it.
Okay,
I haven't finished it.
okay,
Uh,
we can start over then. Question 3 would be when you're asking the sample size of n equals 5, what is the shape of the distribution histogram when the parent population is right skewed? We thought it's skewed right, but I don't know if you haven't.
That's what I thought as well.
Okay, good. So normal. Question 4. We thought it's normal because of the size of the sample. As it gets as the size as the sample is larger, it gets closer to the
Yeah.
mean of a parent population. Okay, good. So number 5. When you're taking a sample size of n equals 5, what is the shape of the distribution histogram when the parent population is normally distributed?
hmm
What do you guys think?
I thought it was normal.
Oh, yeah, okay. Question 6. So when you're taking a sample size of n equals 100, what is the shape of the distribution mean histogram when the parent population is normally distributed?
Say normal.
If it's normal, yeah.
hmm
I'm wondering if it's so far I get the impression that there's some trick questions there because it seems like the question itself gives you the answer, but I don't know.
Yeah.
But anyway.
Yeah. Well, the way I see it, like they've given us no other reason to think otherwise.
Yeah.
At
Okay,
least with
so
these previous 2 questions.
okay, so number 7, right?
Mhm.
Number 7. Yes. When would the distribution of mean be normally distributed?
I put both cases where the sample size is large.
Yeah. Because it tends to
Yeah.
be similar to the parent population. Okay,
Mhm.
good. Number 8. Which of the following gives a basic explanation of the central limit theorem? That would be
Like I put the one at the bottom. At least that's the one that sounds closest to me.
this one is for large number, the law of large numbers.
Right.
This is the 68, 95, 98, 9.7 thing.
Mhm.
So yeah, it would be either this and the first one, if the parent population from which data are drawn, it's normally
Mhm.
distributed the sample mean.
I think it's the
Yeah,
bottom.
the last one. Yeah. Okay. So here we get the
Here it gets a bit tricky.
yeah,
Let's,
the tricky
let's
one
start
is
adding
that.
numbers.
Yeah. Okay. Somebody wants to read it or
Let X be a random variable with a population mean of 10 and a population standard deviation of 6. Suppose the sample size is 36, is drawn from this population. What is the mean of the distribution of sample means?
okay.
I kind of had to look back in the text for that one. There's a similar problem toward the end of the chapter.
Mm-hmm.
Let me look for it. Let me see if we can pull it up. You want me to look for it on look for it on the textbook. So you at the end of it, this
Towards it, like under the section where it says mean and standard deviation of the distribution of sample means.
this one
Right there.
here.
Right there, yeah, that one.
So
So I
is
kind of
this
I kind of followed along with that one.
okay?
The wording appears to be about the same.
Okay. And of this one right here, of this exercise.
Right.
Okay. Let's see. So image sample is here.
Like notice how the mean that it gives in the solution is the same that it's giving in the question.
Oh, it's the same mean. Okay, because it's
Yeah.
that might be because the sample is large and it tends to be closer to the population mean. Is would that be the why?
I would think so.
Right. Yeah. The only thing about that though is that I cannot figure out how do you decide if the sample is large enough.
I think it said it like at the end of the chapter, it says here in bold, for this course, if n is greater than 30, we'll say the distribution of sample means will be approximately normal.
Oh, okay. There you go. I missed that part. I didn't got that far. Okay, so yeah, that's the answer. So if it's 36, we consider it large enough to be close, approximately normal, so close to the population. So in this case would be 10 then, right?
Right.
Okay. Good. So what is the standard deviation of the distribution of sample means?
So going back to that question, it shows you the equation for figuring that out, and it's actually a lot simpler than
Isn't
than
it just like the
looks.
standard deviation divided by the square root of n?
Right.
Right here.
So you take the standard deviation, that'd be 6, and then the square root of the
So 10 divided by 6.
Yeah.
Okay. You want me to do the calculation here on the screen? Let me see if I have a calculator. So
It's 1.67 for rounding.
how many decimals are we supposed to
like it's standard deviation over the square root of n.
And in this case, n.
So that'd be 6 over the square root of 36, which is 6. So
Would
that'd
be
actually
one.
be 1.
1. Oh yeah, sorry. I did 10. I don't know why I did 10.
That's all right.
Okay.
I calculated with the mean.
It's easy to get them
Okay.
confused.
Mm. Okay, question 11. Regardless of the distribution of the population, if the sample size is large, what would be the shape distribution of the distribution of the sample mean?
I think we just went over that. Be normal.
Yeah, well, it's normal, right? Because it's large.
Mm-hmm.
What theorem would justify the response to the last question? That would be the law of large numbers, right?
Let me double check that.
Is let's see, it says here, it was on top here. Where was it?
Yeah, without like checking the book, I think it's law of large numbers just because like the more people you add to the population, the more likely it is to like get to that normal shape.
Yeah.
Actually, I think that's the central limit theorem. The law of large numbers says as you grow the as you expand to include more of the population, the mean of the samples actually gets closer to the population mean.
Let me see this. I wrote that down here on a. So I got for law of large number, the greater the amount of observations, the sample mean gets closer to the population mean.
Mhm.
And the question was again, let's see. So regardless of the distribution of the population. Okay, because it's okay. And this central limit theorem will be the sample distribution of a sample bill will be approximately normal if the size of sufficiently large. The sample size becomes larger if it gets closer to the perfect distribution. I don't know where I put perfect there, but that's not the one. Okay, yeah, I think it's in this case it would be the central limit theorem because it says here that it's regardless of the
Yeah.
distribution of the population, and the definition it would be that.
Right.
Yeah. Okay. Okay. Let's submit this. See how we
See
did.
how we did.
Got that right.
100%.
100%. Oh. Here.
It looks like we missed one on question 7. Maybe
Yeah.
forgot to check.
Oh.
Maybe forgot to check one off.
Or maybe it was only one of them, or it doesn't say.
Because it's both the large ones and then it's the small one that's normally distributed.
Oh,
Oh, this one here. Okay. Okay. The rest was all
it's
good.
okay. It's okay. You can go back and fix that.
Okay. Okay, good. That's pretty much it. Do you guys have anything else that you want to discuss or talk about?
I think I'm good.
I'm good too.
Yeah, I'm
So
glad my Wi-Fi decided to work for long enough for me to join in. So
Mhm.
yeah, we didn't. I mean, we were just starting. You connect right on time. So
Mhm.
okay, guys. So on Thursday, is this time okay with you? You want to do it a little earlier?
Mhm. Yeah, a little bit earlier would be good. Like I usually have to work at 2, like on both Tuesdays and Thursdays. So
Okay.
where are you at?
I'm out here on campus actually.
Oh, okay.
So what time is it there now?
It's about 1:30 here.
1:30. So we can do it at
Around 12:30 or 1 works for me.
okay, good. So that would be
That'd be
Three- 3 my time.
that'd be 8:39 my time.
Okay, good.
Wow, where are you at?
Cyrus, I think that was for you.
Oh, sorry, he cut out for me.
Uh,
What'd you say?
What, like, where are you at? That's a huge time difference.
I'm in Slovakia.
Oh,
Yeah, my family lives here. My dad's new job, so I'm
Cool.
spending the summer with them here on my off track.
awesome.
That's
It
cool.
makes coordinating with people for classes difficult sometimes, but
Yeah, I hear you.
Are you going back to the States after summer? Or?
after in July, I'm gonna head back,
Okay.
do some summer classes and stuff.
All
That's
right.
good. Okay, guys, thank you very much for your time. I'll talk to you on Thursday then.
Yeah.
All right.
Talk to you Thursday.
Yeah.
All right, bye.
Bye bye.
Bye.